Welcome to the first lesson in the Python webinar series. This webinar series will aim to give you the understanding and expertise necessary to use Python in conjunction with Itasca software to further your modeling capabilities. In this lesson specifically, we'll be going through an introduction to Python, which will later serve as the fundamental backbone to expand our knowledge. So while most Itasca software such as FLAC3D and 3DEC has Python natively available within it, if you want to write Python code outside of these programs, you'll have to firstly download Python from this following link, making sure to install the correct version for your OS system. Now, when you install Python through here, it will also install a program called idle. And opening this program will show this window here. Now, this is a Python shell, which will allow you to write Python code in it, and the program will kind of execute dynamically as you write the code. However, practically, normally we want to write pre-built scripts which will execute in its entirety. So throughout the course of this lesson, as I go through and make examples, I'll be writing these examples in a new Python file, which I will then execute by going to the run and hitting the run module button. And so it might be helpful to pause the video and go to this link here so as to download Python so that you can follow along with the examples as I go forward through them. Now, Python is a programming language, which fundamentally means that the function of Python is to store some initial data and to manipulate that data to get your final resulting values. Now, there are various different types of data, and the data can range in complexity from a simple number to an abstract concept. But within Python, there are three main primitive data types, which the other data types are then founded upon. The first of this are integers. Now, an integer in Python simply represents the same thing as a normal numerical integer. So it represents the range of all positive and negative as well as zero whole rational numbers. Now, the second primitive data type within Python are floats. Floats represent decimal numerical values. And the final primitive data type are strings. Strings represent any collection of characters. Now, it's important to note that these data types can represent the same data value. For example, the integer of 3 represents the same concept as the float of 3.0 or the collection of the 3 character. However, these differ in the Python language in how these data values are being stored as different types, which, as we'll later see, allows different operations to be performed on these types of data. Now, within Python, data is stored within variables. And these variables are initialized in Python via simply writing out the name of the variable, followed by the equal sign, followed by the data. So, for example, in this following code snippet, 3 different variables are initialized. One called string_1, which contains the data hello world as a string. A second variable is initialized as int_1, which contains the variable 10, and the final variable float_1 is initialized with the value of 1.3. Additionally, variables can be initialized using other variables. For example, in this code snippet, a variable x is initialized to hold the data 5. So afterwards, we have that in our code, x is equal to 5. The second line initializes y so as to hold the data within x. So after this, y will then be equal to 5. Now, the print command within Python can also be used to output the contents of a variable to the standard output. So for example, if we used our priorly defined variables and used this syntax to print them, we would first output hello world, since that is the data contained in string 1, followed by 10, and followed by 1.3. Now, once data has been initialized or prior to this, arithmetic can be performed to do computations and other mathematical operations. Now, the standard syntax for this represents the normal mathematical syntax. So plus is for addition, minus is for subtraction, and so forth. An asterisk represents multiplication, and two asterisks represents exponentiation. So this line here would store in the variable int underscores 2 the mathematical result of 1 plus 3 to the power of 2 minus 4 times 2. And in this second variable, it would be initialized to contain the data 5 divided by 2. So afterwards, int2 would store 2 and float2 would store 2.5. Now, an additional kind of confusing arithmetic that Python presents is called string concatenation. So what this allows you to do is to combine different strings together. So for example, if you have a variable hello, which contains the string hello, and you have a variable world, which contains the string world, Python allows you to concatenate these strings together with the plus sign, which then simply combines these sets of characters to create the string hello world. Now, it is also possible within Python to cast different types of data to one another. So this is done by using the keywords for the respective type of data that you're trying to cast to and putting in your input data within the parentheses. So for example, in this first line, the float 3.9 is passed to the int command, which will then cast 3.9 to an integer. Now, when casting between floats and integers, Python truncates it, so it doesn't round it up. So even though this is 3.9, it will return 3 as the value. Furthermore, 7, when it's casted to a float, will return 7.0, so representing a float. And 5.2, when casted to a string, will then represent 5.23 as a string. So now we can use our idle editor to create a possible example of the features of Python that we've seen so far. So specifically, I'm going to showcase how we can use what we've covered thus far to create a simple program which will take the average between two values. So firstly, we can initialize some variable x to contain our first value, and some other variable y which will contain our second value as a float. We can then use arithmetic to calculate the average of these two values, and then use the print and int commands to cast the average to an integer and output it. So if we save and run this, we'll see that 9, which is the average between 5 and 13 truncated, is outputted. And so you can already see that through just a little bit of Python code, we're able to begin to build powerful computational math and mathematical solvers. Now that we've seen how you can initialize and modify your data, we'll now be going into how within Python you can dictate when and how your code is executed based on different conditions and iterative structures. So firstly, within Python, there are several different syntactical measures which can be used to equate to different Boolean conditions. So specifically, two equal signs represents the equal to Boolean condition, not equal represents not equal to, a greater than sign represents greater than, and so forth and so forth. These conditions can then be applied to data to return true or false Booleans. So for example, in this code snippet, x is initialized to 2. This first print statement will then print whether x is equal to 3. So this will print false. The second statement will print whether x is not equal to 2. So this will also print false. The third will print whether x is greater than 1. So it will print 2, true. And the final will also print true. Now, if statements can be used within Python to dictate whether some code should be executed based upon a Boolean. So the syntax of if statements in Python is the if keyword followed by some Boolean, colon, and then on the next line, indented forward your code. So, for example, you might have if x is greater than 0, and then on the following line, you can have print positive. Now, one important thing to note within Python is that whereas other programming languages use curly brackets or other syntactical measures to separate your code, Python uses indentation. So you'll notice that this second line is indented, and we kind of represent this as being within the for statement. And it's very important that any following code lines that you also want to be within the if statement are indented to the same amount that this first statement is, else Python will crash because it won't know how to read this syntax. Now, a similar statement to the if statement is the if-else statement. This statement means that if this first Boolean evaluates to true, this first section of code will be executed. Else, so if this Boolean is evaluated to false, this second segment of code will be executed instead. So for example, this example uses a special operator which uses the $sign and represents the modulus operator. So it returns the remainder of x divided by 2. So in this example, if the remainder of x divided by 2 is equal to 0, this code statement will print even. Else, it will then execute this line of code and print odd. Now, it's also possible to include additional if branches within an if-else statement. So in this code, for example, this first Boolean is evaluated initially. And if x greater than 0 evaluates to true, this print x as positive statement is executed and the rest of the code is then ignored. If this first Boolean evaluates to false though, then this second Boolean is evaluated next. If this second Boolean x is less than 0 is evaluated true, then this print statement here will be executed and x is negative will be printed. If this second Boolean evaluates to false as well, then the final print statement will be executed instead. Now, it's also possible within Python to combine different Booleans. And there are two main ways to do that, either using the AND keyword or the OR keyword. Now, the AND keyword will evaluate to true if and only if both of the expressions on the left and right are true, and the OR expression will evaluate to true if either expression is true. Now, it's also possible to negate Booleans using the NOT operator. So not true will return false, and not false will return true. Now that we've covered conditional logic, another important concept to understand within Python is iterative execution, which allows us to execute a certain portion of our code a certain number of times or until a certain expression becomes true. So a for loop is a Python structure which allows you to execute some statements of code a specific number of times. And this is the standard syntax for a for loop within Python. So we can see that we have the for I keyword followed by a variable declaration of I, followed by the in keyword, and followed by the range function. And then after this colon, we then have another, similar to the if statement, we have another indented segment of code, which is then going to be executed iteratively via this looping structure. So what this looping structure does is that it will iterate this indented code 5 times using the values of I from 0 to 5 exclusively. So in the first loop, I will be equal to 0, and it will execute all of this code. So it will print I has a value of 0, so it will print 0. In the second loop, I will then have a value of 1, so it will print 1, and so forth, until 5 exclusively. So after this, when this code is executed, it will first print 0, then 1, then 2, then 3, before finally printing 4. And that is because of the argument passed to the range function given 5. Now, these arguments, though, can be made more specific based upon your needs. So for example, if instead of starting if you didn't want your loop variable I to start at 0, you can pass another variable to make it start at a different initial value. So for example, in this case, I will now start at 3 and increase till 6 exclusively. Finally, you can also pass a step variable so as to change the interval which I increases. So in this case, for example, I begins at 3 and increases with a step of 2 until 9 exclusively. So 3, 5, and 7. An additional looping structure is the while loop. So whereas a for loop will execute a set number of times, either based on the arguments given to range, a while loop will execute while some Boolean expression is true. So in here we have the same a code example which will achieve the same functionality as the first for loop example, but since it's a different structure within Python, the code is slightly different. So we can see here that our conditional expression is count is less than 5. And before this while loop, we initialize count is equal to 0. And then we can see that our indented code, every time this is executed, will firstly print count and then increase the value of count by 1. So on the first iteration, count will be 0, so it will print 0, and then it will increase count to 1. After that iteration, this Boolean expression will be evaluated. So whether count is less than 5. Well, count is the value of 1, and 1 less than 5 is true, so this expression is true, so the while loop continues. And thus, this segment of code printing count and incrementing count continues until count less than 5 evaluates to false, which occurs when count is equal to 5. So because of that, this code will print first 0, then 1, then 2, then 3, then 4, and so forth. So in short summary, a for loop is preferential when you want to iterate over some code a specific number of times, whereas a while loop might be more preferential when you want to iterate over some code while a certain expression or a certain conditional expression is true. So once again, we can showcase what we've covered thus far with an example within the idle editor. So specifically, we can cover an example for determining whether a given integer is positive, negative, or 0. So say we have some integer given via x, and in this case, it's simply written within the script, but later on, this could then be read from a file or from some mathematical computation or from some number given via your model. So we can then use the if, elif, else structure available within Python to determine whether this given variable x is greater than 0, equal to 0, or less than 0. So if x is greater than 0, we can output that x is positive. Else, if x is equal to 0, we can output that x is 0. And else, we know that x must be negative. We can now showcase that this code works by running it. So when x is 10, it returns that x is positive. If we set x equal to negative 10 and run this, x is negative is outputted. And finally, if we set x to 0 and run it, we see that x is 0. And so thus, via just kind of very simple Boolean logic, we can begin to have some powerful determination of when our code is executed. Additionally, we can use for loops in a variety of manner to iteratively compute or to iteratively execute our code. And one classical example of when this would be useful is if you wanted to determine the summation of all numbers less than a given integer. So say we're given some integer n, so for example 9, and we want to compute the sum of 9 plus 8 plus 7 plus etc. to 0. Now, there are kind of, if you know the given value of n, we could simply say, okay, our result will be 9 plus 8 plus 7 and so forth. However, if n is just some random integer given, it's very difficult to write non-iterative code to compute this. However, with for loops, it's actually very simple and easy to do so. And so to do so, we can create another variable called sum so far, which we initialize to first be 0. And then the number of times we will loop will be in the range from our initial number n to, we want to be to 1, so the last integer, so we can say 0, with a step of -1. So starting from n to -1, going until 0 exclusively. So our last variable of I will be equal to 1. And then we can simply say sum so far is equal to sum so far plus I. Or a way to that Python has some simple syntax to make this kind of neater is instead of making it be like x is equal to x plus something, we can simply write sum so far plus equals to I. And then at the end, we can say print the value of sum so far. So for initial demonstrative purposes, to verify that this does work, let's say we have n equals 3, we run this, and we see that 3 plus 2 plus 1 is in fact 6. Similarly, if n is 5, then we get a value of 15, since 5 plus 4 plus 3 and so forth is 15. And thus you can see that with kind of very simple and neat code, we can generate this kind of powerful iterative method of execution. And we can also change this to calculate factorials by, instead of simply adding on every time, by multiplying. And now suddenly we have a way to calculate factorials. And simply starting, of course, with sum so far. If we want to have this as factorial of n, we have to start with 1 since we're multiplying rather than adding on. And so then running this, we can see that passing in n as 5 and calculating a factorial, we get 120. All right, we've now covered how Python stores and how you can manipulate data, as well as how you can dictate when and how your code is executed. The next thing we'll be covering now are functions within Python, how you can define executable processes within your code. So a function is simply a collection of code which you can then execute at any time later in your code simply by calling the keyword of the function. And this is the syntax for defining a function in Python. So we use the def, the def keyword, followed by a space, followed by the name of your function. So in this example, I've titled the function my_function, but you can title this whatever you would like, followed by open and close parentheses, and we'll cover later the significance of these, followed by a colon, and then on the next lines indented all of the code within the function. So for example, in this function, the code simply prints hello from my function to the console. So if this is then our code snippet after we've defined this function, if we print hello and then call my function, well, this will firstly print hello out to the console, and then when my function is called, it will cause this code statement printing hello for my function to be executed, and thus hello for my function will be printed. Now, arguments and parameters can also be passed to a function. So when defining a function within those parentheses, you can declare the name of variables and arguments which must be passed to that function. So for example, this function takes in a name parameter and an age parameter, and then prints hello with the name and UR with the age casted to a string. Then to call that function, we simply state the name of the function, have an open parentheses, pass in a string for the first parameter and a integer for the second parameter. And this will cause then the code to be executed with name equal initialized to hold the first parameter. So name will be initialized to be equal to Bob, and age will be initialized to be equal to 33. So then hello plus name will be hello Bob, and UR plus age will be UR33. Now, an additional feature of functions within Python is returning values. And this allows you to segment some of your computations or your code into an external function and then have it return the resulting value back to your main code. And that is accomplished using the return keyword. So in this example then, now when you call sum to numbers and, for example, pass in 5 as your value of A and 7 as your value of B, that will return the resulting summation of those two numbers. Now, one thing you have to be careful with in Python is that there's not really any way for your variables to automatically check the type of a variable. And so because of that, in functions, when you're passing data to as arguments, you can in fact pass data which is not of the expected type. So for example, this function is meant to sum two numbers. It takes two numbers and returns the sum of them. However, you can pass in strings, and because string concatenation is available within the Python functionality, this will work and will return hello. But if you pass in numbers of different types, this will actually cause an error and cause the program to crash, because Python does not know how to add a string to a number. So that's just one thing to be careful of when creating your own functions and calling your functions, is that you are passing the appropriate data type to what the function expects. Now, an additional feature of functions in Python are default parameters. And default parameters are simply parameters which, if you don't pass a value for them, they'll have some set value. So typically, if a function requires two parameters and you only pass in one, the program will automatically crash. With default parameters, however, you can avoid that error and still have some sort of generalized behavior. So the syntax for defining default parameters is within these open parentheses. When you're defining your function, you have the variable name. So for this example, it's C, equals to then its default value. So in this case, for example, we're initializing that C will have a default value of 2 and D will have a default value of 1. So we can see then that if we call the functionality simply with two variables, it will still execute correctly and won't cause an error and crash. Additionally, we can still choose to pass in parameters for the values of C and D, and the code will still execute as expected, since these values will only be set to C and D if nothing else is passed for them. Finally, another feature is that if you only want to use the default value for one or for a certain number of the variables, you can also specify when calling a function the specific value that you want for a specific parameter. So to do that, you then state the name of the parameter, so in this case D, equals to then the value which you want to set for it. So going back to our prior code example, we can actually showcase a example of the effectiveness of functions by turning our code here, which computes factorials, into a callable function. So before we simply kind of had the value of n stated. However, what we can do instead is turn all this code into a function, which say is called simply factorial, and which takes in a parameter n, and then simply calculates the factorial of n using our prior code. And remember, within Python, the kind of segmentation between if clauses and functions is determined by indentation. So it's important that we have all our code properly indented. And then we can simply have that after this function is executed, our factorial is returned. So we can now simply call our function with various values, and this just kind of showcases the effectiveness of using functions. Whereas priorly, if we wanted to, say, do 3 separate calls, we would have to copy and paste this code over and over and over again with different values of n each time. However, by putting all of our code into this single function, now all we have to do is simply call the function different times, passing in different values of n. So if we run this, we can see that 5 factorial is 120, 4 factorial is 24, and 2 factorial is 2.